Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. Today's demonstration is inspired by a component for the mini lathe that I did off camera that I had hoped to share with you, but the detail was just so small it was ridiculous. It was like doing a colonoscopy on a mouse. Sure, you can do it, but you can't get a camera in here, right? Pretty much the same exact thing that just happened. I had to bore a 4/0 taper in a piece of 3/16 diameter steel. A 4/0 taper tapers approximately 5/1000ths of an inch per side per half inch. So that is not a whole lot. That is 21 thousandths total change per side over 2 inches. 21 thousandths. That's really slight. Now you can buy a reamer for that and just spend 35 bucks and do it and put it in your box and you're good forever. Or you can learn how to single point something like that and bore it. And I bored mine with an 0.80 diameter, 2 millimeter diameter carbide boring bar. I'll show you the bar. It's pretty small. It's pretty cool. Anyway, the technique, I've already covered this on this channel, and it's setting your compound to precision angles. So if you haven't had the opportunity or desire to sit down and watch 260 videos, geez, I don't blame you. This is a good refresher course. So let me show you what I did. I know on my machine that I have 3 inches of usable stroke on my compound. Let's use a 30-degree angle because I know that's what my machine is currently set to. I want to draw that nice and big so you can see it. .30 Now 30 degrees as compared to center line of the machine. First thing we got to do is do a little bit of math. 30-degree triangle. And I'll bet you that's pretty close to 30 degrees. 3 inches here on the hypotenuse, because that's what I'm going to do with the compound. I'm going to articulate the compound 3 inches. So we need to know this distance right here. And whatever angle that you're using, calculate that for the height of the triangle. And on a 30-degree triangle, that is 1.5. It is very important to mention right now that you need to know what kind of dial you have on your machine. And believe it or not, I bet you have 2 different kinds of dials on your machine and didn't even realize it. First dial being the main dial, the cross-slide dial, that when you dial in 10, the part that you're working on gets 10 smaller. Well, that is called a diameter reduction dial. Diameter reduction dial, that's what I know it as. If it's called something else, put in the comment line, let me know. Diameter reduction dial gives you exactly what you think you have coming off the diameter. So technically, the cross-slide dial on your machine, let's say 1 revolution of your dial is 200. The carriage or the cross-slide did not just move 200, it moved 100 because it's removing 100 off the front and 100 off the back because the part's spinning, so the diameter gets smaller by 200. The compound dial, if it was still 200, and most of them are 100, mine is, as you spin that handle 1 complete revolution and it goes all the way around to 100 and back to 0, it will have actually moved that distance. So that is a radius reduction dial. If you turn your compound perpendicular to your work and use that for turning, it will cut off twice as much as you asked for. So if you dial in 10, it's going to cut 20. That's the difference. Figure out what you have. It's really important to know what you have for this particular thing right here. I'm going to put an indicator on my top of my compound and rest that indicator against my tool post. When I move the compound 3 inches without moving the carriage, I should be able to dial in 1.5 inches on my cross slide and have the indicator come back to 0. So just to illustrate further. Indicator sitting right here, connected to the compound. It's on 0. When it slides all the way back here and I move it in, that indicator should come back to 0. And if it doesn't, Keep smacking it with a wrench, a hammer, or whatever you need to do to tweak it, to move it, until you get your numbers to line up. And you're going to have the tightest angle you can possibly imagine. Now use a large number. Use the largest run that you can use on your machine, because it'll help you to dial in the error. Now the angle error will always be the same. Like, oh, I'm off 1 degree over a course of a mile. Well, a mile out, it might be 100 yards across, but at a foot out, it's only going to be this big because you used a mile as your standard. Same thing here. Ranges. Let's take a walk out. I'll show you the compound. I'll show you the indicators. I'll show you the movement and make this perfectly clear. Let's take a walk. Okay, this is a solid center. It can be applied and used as a dead center, a live center, whatever. Now, if a center spins, it's considered a live center, but the movement should be contained within the unit itself. So technically, any day of the week, this is considered a dead center. It can be used as a live center, but it's a dead center. Now let's take a look at how small the dead centers are for the lathe I'm building. And believe it or not, that's a tapered center. It really is. I will do everything I can because I'm doing this with one hand right now, so bear with me. All right. There is the spindle for the mini lathe. That is the hole that I had to bore, and this is the little center that had to fit in there. There you go. Big difference in the two. And I can guarantee you that that angle is spot on. Let's take a walk over to the lathe and review that setup I just showed you on the board. That's pretty small, huh? I think it is very important to demonstrate exactly how precise this setup can be. So to do that, it's really important that you know something about angles. A 1 degree angle at 1 inch long will rise 17.5 thousandths, approximately 0.45 millimeters. It's a little bit less than 0.45, but it is really close. Now, it's easy to remember this number, for me anyway, because 17.4 is a very popular surgical grade heat treatable stainless steel. So 1 degree at 1 inch equals 17.4. Great. What if this isn't 1 inch? How does that play out? What do you do? Is this 3 degrees now? No, it may be. Or you could look at it this way. Take a bunch of those little 1 degree triangles and just add up the stacks for every inch that you get. Okay? 3 inches long, boom, 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 3 stairs, 3 times 17.4, 52 thousandths of an inch. 3 inch long, 1 degree error projected. 52 thousandths of an inch. That's about 1.5 millimeters, almost. Knowing this, exactly what do we have here? What is this 052.2? That is 1 degree at 3 inches, but let's break it down. One degree error at 3 inches is 052.2. Now half of 1 degree, 30 minutes. That's half of 1 degree. Most prints that you get are not going to take you beyond this as a tolerance for an angle. 30 degrees. Or excuse me, 30 minute. A 30-minute error at a 3 inch projection on an indicator will give you a 26 thousandths total range when you try to set your compound. Split this in half again. 15 minutes. That's a 1/4 of a degree. That is incredibly tight. 13 thousandths showing up on that indicator. I'm not saying no, I'm just saying there's the needle moving around 13 thousandths. 13 thousandths on that indicator. And believe me, you won't have a problem hitting that. You take 1 degree is composed of 60 minutes. Right here, 1 minute, one of those 60 minutes, 1/60th of a degree, at our 3 inch projection, 8.5 tenths, or 0.22 millimeters, I believe. If I'm wrong, correct me on that. So you can see, based on the triangle that you decide to set up with your compound and the reading that you get with your indicator, how close you really are to the angle you're looking for. The greater the distance, the bigger this number will be, the easier it will be to set that. All right, let's take a look at the machine. My machine is set up for a 3-inch hypotenuse right here. This is the same exact drawing from the board. I'm going to use a 3-inch motion on my compound to do this, looking for an 1.5 inch movement on my cross slide, and I will set my zeros on my indicators here and look for it to repeat here. If it does not repeat here, that will tell me if this is larger or smaller. If it's larger or smaller, that will tell me if this angle is smaller or greater than the desired target. Let's do it. To begin the demonstration, I will show you that I have punch marks in the side of my compound that I know are 3 inches apart. Okay? I'm using the end of the compound as my zero indicator. As long as that dot is lined up with the end of the bottom casting, I know I'm in line where I need to be. My cross slide dial is set at 0. Imperial. I know you're right. Watch this. I might be sorry I did this, but I'll flip it over here and make all you metric guys happy. Look at that. Oh, metric. Tell how much I use that. I might actually have to wash my hands or break out in a rash after seeing metrics like that close to my fingers. The indicator pressed up against the tailstock also set at 0. I'm just having fun with you metric guys. That's just a language I never embraced, so everybody that can do that, God bless you. Compound set on 0. Indicator set on 0. Cross slide set on 0. Compound stroke set on 0. Looking at 30 degrees. Okay? I need to back this compound off 3 inches. That's the hypotenuse of the triangle. So I'm going to back this off 3 inches. I'm going to hand hold this and go fast forward on it, but I will return to that spot right there. Do not touch the indicator. Do not touch this dial. Back this one off to the second 0 position. Right there. Bring it back. I'm going to go beyond it and come back to it because that's how I zeroed the 3-inch position. Zero. We are now at the very bottom of the hypotenuse. The indicator is off the tailstock. We now have to move the cross slide in 1.5 inches. Knowing the dial setup on this machine, I have to turn the dial equivalent of 3 inches to get this to move 1.5 inches. So 15 turns. This is 200 around, 15 turns.
That's 14.
Now I'm going to pay attention to the indicator for now. I'm going to turn the cross slide dial without even looking at the numbers and wait for this to come back around to 0. All right. If this is exactly 30 degrees, my cross slide dial is also on 0. Which it is not. So we turn this 15 times plus 3 thousandths. So this is 3 inches, 3 thousandths. What does that mean? Well, that means that the compound has a larger than 1.5 inch drop because it didn't take 3 inches to get there. It took 3 inches and then some to get there. So this angle is larger. If we travel farther, it's a greater angle. If you travel less, it's a smaller angle. Now, is this a big deal? Should I change that? Well, You know I would change it, but how close are you at 3/1000 of an inch out? Let's go back to the cue cards here and find out, right? 3/1000 of an inch out. You're about 4 minutes. 4 minutes. That is about 1/15 of 1 degree out. Way within the 30-minute. 1/15 of 1 degree. Not 15 minutes. 1/15 of 1 degree. 4 minutes. Or imperial or metric. 4 degrees. There you go. Should I change it? Absolutely not. That is as close as you're going to want to get. If you want to tap it in, if you're doing a seat, if you're doing some type of hydraulic system and you really want to tap it in, unloosen the bolts, tap it in either direction, reset everything and check it. It might take you 2 or 3 tries to get this, but it is going to be well worth learning this technique. Let's bore a plug, or let's make a plug, turn a plug taper, and bore a conical taper in a piece of material, and I'll show you how to control where that plug sits in that taper. Very much like I had to control the depth of the dead center I made for my mini tailstock. I'll show you how that was done. It's not nearly as hard as you would think. First half of this operation, I am going to make a 30-degree tapered plug that's 30 degrees per side, 60 degrees included. And I'm going to show you a technique that you probably haven't seen before, but if you've ever turned a plug and a tapered bore, you know that you have to reset your compound to do both of them, right? The compound goes one way for one way for the other. Well, the only way to be sure that the angles are exactly the same is to not move the compound. And to do that, I am going to turn the OD taper with the boring bar with the machine running in reverse. This is my favorite boring bar. It is a solid rock machine shop product. And Steve Martin gave this to me at the bash out in California a couple years ago, and I tell you, I just love it. So look them up. Look them up on YouTube. Look them up on the internet. Great bars. I love them. Let's do it. Going to put a bigger piece in, do a 30-degree internal taper, 60-degree included, and then we're going to control the depth of that plug. I'll show you an easy way to do that. As I start the bore, I am moving my cross slide out to get a larger diameter until the plug will sit in there. And we'll figure out exactly how to get this plug at a certain depth. Right now I'm using the cross slide to control this cone. I just zeroed out my digital readout. I'm going to pull the tool out now. Don't move anything, just the carriage. Now, if you have a specific distance, it's a very small land there, so forgive the rocky nature. If you have a specific distance from the face of your plug that you need to maintain or engage, measure the height, and when you want this to go a little bit deeper, simply move the carriage in without touching the cross slide. Okay, this looks like about 1/8 of an inch more until this is tangent to the face. Let's see if that works. Do not move the cross slide now. Use only the carriage and the compound. Whole carriage out. And if there's any merit whatsoever to this technique, the edge of this plug should now be true to the face of this part. And it seats like a rock. Okay? This is exactly how I control the projection of the little dead center that I used for the miniature lathe. I knew how far out I wanted it to stick. Once I got a contact diameter that I was happy with, I measured the projection, and then I moved the entire setup using the carriage to get the projection that I wanted. Works well. Use them together and you'll have a lot less stress. That's all I got for you guys. Thanks for watching. Joe Pye here at Advanced Innovations in Austin, Texas. Now I'm out.
Nice.